Good afternoon, Dr. D. This is Matt Argo. This is my presentation for my X-ray circuit and my X-ray tube. As you see, I have drawn a diagram of my X-ray circuit as well as a diagram of my X-ray tube, and I will explain to you how they work. I'm going to start off with the X-ray circuit. This section right here is the whole X-ray circuit. We have our main circuit up top and our filament circuit down low. On the left side of the main circuit, we have our low voltage or primary circuit. On the right side, we have our high voltage secondary circuit. And down low, we have our filament circuit, which is all one. I'm going to start off with an example of 80 kVp, 15 mA in 2 seconds. I'm going to enter these into my control panel, and it's going to set the X-ray circuit up for whatever needs to be done with it. As I go through, I'll explain all the different steps and different meters and so on and how they work. I'll first start off with letting you know that there's going to be 220 volts that are going to enter a building from a transformer that's on the outside. And once it enters a building at 220 volts, once we hit this main switch on the X-ray circuit, those 220 volts will be converted to 110 volts. And 110 volts will be flowing through this entire circuit up to a certain point, and as well as the current that's coming in through the building into the X-ray circuit will be alternating current. So once we hit this main switch, it's going to convert the 220 volts into 110 volts. And at this time, we're going to have 3 lines of electricity going at the same time. Our first line is going to start here, and it's going to go up to the top of this portion right here. Our second line will meet at the bottom portion here. And our third line of electricity is going to start here, and it's going to go all the way down into our filament circuit and to this point right here. Now at this point, I already entered my 80 kVp, my 15 mA, and my 2 seconds on my control panel. This very first point is a auto transformer for our kVp, so once I select that and I put the 80 kVp on my control panel, this kilovolt meter is going to read that I put 80 kVp in my control panel. It's going to send this dial to the correct number of kVp that I selected, which is going to be at 80. At the same time, my 15 mA, the electricity that circuit or current that's flowing down to my filament circuit, here we have a filament ammeter, and what that does is it's going to read the amount of mA that I put in on my control panel, and it's going to send this dial to the correct number that I selected. Up here we have a timer, and our timer is going to be our seconds. So I selected 2 seconds on my control panel, so this timer is going to read 2 seconds. And what that does is that's going to be the amount of time that exposure is going to happen. So once we have all of our control panels set, all this is flowing at 110 volts. This is our first auto transformer that we're going to be dealing with. Once I hit this exposure switch, it's going to allow electricity to flow through the rest of the circuit for the approximate time that I set on my control panel. So when I hit the exposure switch, if this is my exposure switch, I'll press down on my exposure switch. After the 2 seconds of exposure has happened, I will get a blinking sound and a blinking light to let me know that the 2 seconds is up. I will then let my finger off the exposure switch, and at that moment what's going to happen, if you remember, all this is flowing at 110 volts. We're going to get to this transformer, which is a step-up transformer, and what a step-up transformer does is it takes a low amount of voltage and it converts it into a high amount of voltage. For this X-ray circuit specifically, we're looking to get 10,000 volts into our secondary. So what this step-up transformer does is it's going to convert that 110 volts into 10,000 volts. At the same time down here, we're gonna have a step down transformer, and what that does is it takes a high amount of voltage and it converts it into a low voltage. So again, we're starting off with 110 volts. We're gonna use a step down transformer to convert that 110 volts into 5 to 15 volts or 3 to 5 amperes to make sure that we're getting the correct amount that we need. Staying down here on the circuit, after we convert that 110 volts into 5 to 15 volts or 3 to 5 amperes, it's going to follow up into the Xray tube, into the cathode side, into the filament, and it's going to start to warm up the filament as a warm-up procedure. Once we get back up to the step-up transformer, this here MA, which is a meter, reads that the correct amount of voltage is being converted. If it's not the correct amount, let's say instead of converting from 110 to 10,000, it converts it to 6,000. What that will then do is it will come back into the primary side and it will sit there and it won't be used. On the opposite side, if we get more than 10,000 volts, let's say it goes to 12,000 volts, what it's going to do is it's going to go down into this ground. Right here is a ground. And this is a safety measure that's put into the circuit so it doesn't overload the circuit. And it's going to sit in this ground, and again, it won't be used. Once we get the correct amount of 10,000 volts, it's going to sit, this 10,000 volts is going to sit into capacitors that are typically around this area. It's not on the diagram, but I'm going to add that in there. So for now, we're just going to pause and we're going to say 10,000 volts, the correct amount read by the meter, is going to sit in our capacitors. Here we have our rectifiers or our diodes. And what this is going to do, if you remember, all this current that's flowing right now is alternating current. And what we need to do is convert that into pulsating direct current. And that's what the rectifiers and the diodes do. So once it gets to the secondary portion of the circuit, it's going to start to rectify our alternating current. And it's going to do that in two ways. The first way, follow my marker. So we're going to start down here. It's going to go through the rectifiers, up through the anode, out the cathode, to the top portion of our secondary. After that happens, our secondary one's going to start, and it's going to go in the opposite direction. It will go from top, it will go down, up through the anode, out the cathode, down to our bottom side of our step-up transformer. At this point, we are now having pulsating direct current. And remember, those 10,000 volts are going to be sitting in these capacitors. And from there, once we have our direct pulsating current, those capacitors are going to then use what we call a falling load generator. And what that's going to do is it's going to allow 10,000 volts at a time go into the anode. At this section, at this part of the circuit, only 10,000 at a time. So if you can imagine, like, it's going to drip down 10,000, and then another 10,000, and then another 10,000. It won't go all at once. So now that I completed the circuit for the Xray circuit, I am now going to explain the Xray tube. So all this is happening before what's happening in the tube. Once we get to the tube that you see here, this is my Xray tube that I drew, and these are the components. We have our envelope, which is what it's made out of, and this is typically made out of Pyrex glass or metal. Metal is probably better because there's less damage to metal. We're going to have our filament circuit, also known as our cathode side, which is our negative. Our filament inside of the cathode. We're going to have our electron beam, our X-ray beam, which is the goal of all of this happening. Our molybdenum neck and base, which is a metal that's made to withstand high voltage high heat in the X-ray tube. Our rotating portion, our anode side, or our positive side, our armature, our stator electromagnets, our bearings, and our tungsten anode. Tungsten is a metal. It's used in the X-ray tube because it can withstand high heat. I believe it's 3,370 degrees or Celsius. This is our anode right here, which is made, this whole thing is our anode. This is our anode plate that's made of tungsten. This section of the anode is made of the polypodium, which is a steel capable of high heat, but not as much as tungsten. And our plate is going to be made with a 12-degree angle. And the reason for that is the best degree that we can get to try to get the most electrons going out of our X-ray beam. We have our stator electromagnet, which is going to help our rotating portion start to spin. And once there's 6 points of induction happening in this whole section, and I'll come back to that, but this is one of them. Once the rotating portion starts to spin, the stator electromagnet will induce the rotor inside of the stator to spin even faster. And what that's going to do is spin the anode plate to a high speed. That's going to help with cooling off, directing electrons down as much as possible. We're going to come over to our filament circuit. Once all this is happening, our filament circuit is going to start creating electrons, electron cloud, and thermionic emission. And I'm going to explain. Here we have our filament, and here we have our focusing cup. And our focusing cup is going to have electrons that are surrounded on the outside, like so. And what these do is we have the law of repulse and attraction. And what these do these are going to repulse the electrons that are coming out, and it's going to repulse them or condense them into a thin straight line, a straight line. And what it's going to do is going to repulse them so we can get a direct point of contact, a direct stream, a direct line of our electrons. Once the electrons leave the filament, thermionic emission is going to happen. Once that happens, our electrons are going to start shooting or going for a direct line towards the anode. Our goal is to hit our 12-degree angle, and they're going to become X-ray photons, and they're going to become our X-ray beam. At this point of contact, that's when our electrons will ionize and change from electron beam to X-ray photons. Now, not all electrons will be ionized and or direct and turn into our X-ray photons. Some of them will bounce up this way and around this way, and what that's going to do is it's going to start accumulating these negative electrons on our envelope. And what that does over time is it's going to cause the tube to start arcing because there's so much accumulation, and that's not good for the X-ray tube. If it gets to a certain point where it's just too many, it could actually break the glass, the Pyrex glass, break the envelope. The metal is used because the metal is stronger, so it lasts longer. But once it's released, once thermionic emission is released, it's going to hit our anode at the angle. They're going to ionize, and that's what's going to create our X-ray photons, and that's going to create our X-ray beam. And that is the end of my presentation. Oh, before I stop, 6 points of induction. First point is going to be here. Second point is going to be down here with our selector. Our third point is here. And the reason why these are inductions is because if this was direct contact, if you follow this line down, you see that it goes to the MA selector or the variable resistor. If it was direct contact, this, which is meant for the KVP, will read what I put on the MA selector, and it will rerun and it will mess up the whole circuit. So that's why it's only going to be induction and no points of contact, so it doesn't confuse the machine or the circuit. So we have 1 induction, 2 induction, 3 induction, 4th induction for our step down transformer, 5th induction for our step up transformer, and our 6th induction on our stator electromagnet. And that makes the anoid spin even faster. This is my presentation, and that completes it. Thank you.